Hello all, welcome to our YouTube channel, My Project Ideas. In this video, we'll be discussing a Python-based machine learning model for image classification. As far as the requirements of building this model is concerned, it requires Python with all the necessary libraries installed that is needed to build this image classification model, and a Jupyter notebook and a CIFAR 10 dataset, basically which stands for Canadian Institute for Advanced Research Dataset, which is the most commonly used and popular dataset to train machine learning and computer vision algorithms. So, with that being said, let's get started and have a look on the code of this particular machine learning model, which will classify the images. So, here is the code in my GitHub repository. Initially, we have imported all the necessary libraries, that is TensorFlow, Keras, Matplotlib for some visualizations, and NumPy for numerical Python calculations. Then we have this is CIFAR 10 dataset is the most commonly used and popular dataset, so you can directly load the dataset in the Jupyter notebook through this particular code: xtrain, ytrain, xtest, ytest equals to datasets.cifar10.load data. CIFAR 10 is a built-in dataset. You can use CIFAR 10 as a built-in dataset. You don't need to download externally on your PC. You can use directly on the Jupyter notebook, as it is the most commonly and popular used dataset to train some machine learning algorithms. Then it contains some 10,000 images with 32,3 dimensions, and all these code updated on a screen is nothing but a proper training and test splitting for the dataset. Next, we have done the classes, that there are basically airplane, automobiles, a bird, cat, deer, dog, frog, horse, ship, and truck. These all are the entities, these all are the classes, and these are the pictures that a CIFAR 10 dataset images contains. That is, it contains the images of airplane, it contains the images of automobile, bird, cat, deer, dog, frog, horse, ship, and truck. So basically, these 9 are all the classes on which we will interact through and will train our machine learning models or neural networks in order to classify the images. Then next what we have done is we have created a function named as plot sample that will decrease the size of the image, or that will flatten the size of the image for the usability, or for the sake of convenience. What we are doing is we are just decreasing the size of the image so that it could be more clear and concise. So this particular code applet decreases the size of an image, and now we have printed some xtrain, ytrain. So at 0th position, the image is of frog. At first position, the image is of an automobile, that is truck. So that it is a built-in dataset. That's why all the images are built in that particular CIFAR 10 dataset. So we don't need to do anything explicitly. All the datasets and images are the built-in the CIFAR 10 dataset. We just need to train our model on the best neural network. Then we have divided the train and test data by using numerical Python calculations, and we have divided by 255.0. Through this particular code applet, we have normalized the images to a number from 0 to 1. Images has 3 channels: red, green, blue, that is RGB, and each value in the channel can range from 0 to 255. That is 256. Hence, to normalize in 0 to 1, we need to divide it by 255. So as you all know that an image consists of basically 3 colors: red, green, and blue. So in this entire universe, you can make any images through this particular 3 colors, that is RGB channel: red, green, blue. So what we have done is, now it's time to train the neural networks. So guys, what we will do is we'll first train our model on artificial neural network. Then we will train our model into convolutional neural network, and then we will compare the accuracy of ANN and CNN. The one with the great accuracy, will choose that particular neural network, and we'll move ahead with the further process and operation on that particular neural network which is of great accuracy. So what we have done is, with the activation function as ReLU, we have trained our model on the ANN first, that is artificial neural network, with an epoch of 5. That is, after each and every 5 iterations, the accuracy will increase. So as you can see that this particular code applet have trained the artificial neural network, and it the accuracy of this particular uh, ANN is calculated through confusion matrix. As we have discussed earlier, that confusion matrix is used to check the accuracy of an algorithm or a neural network. So the classification report comes out to be for ANN comes out to be how much? Let's see the training process. The accuracy is somewhat 49%, I guess. Just a second. Yes. So the accuracy of ANN is 49%, which is less than the accuracy of CNN model, which is 70%. So as you can see that convolutional neural network is with the accuracy of 70%. So we'll use convolution neural network as our neural network to move ahead, because convolution neural network are the ones which is used for image classification, and is considered to be one of the best neural network for the image classification models. So through the confusion matrix and the classification report, we have concluded that convolution neural network is the best neural network for the image classification model. So we'll use CNN and we'll move ahead with the further operations by CNN. So now it's time for prediction. We have decided that we will use convolution neural network CNN models to train a dataset and move ahead with the further operation of the data. So we have evaluate function on X test and Y test. We have predicted the results, and we have predicted for the third, that what would be the image at the third index. So that is airplane. You can actually my Jupyter notebook is not working. It's some technical glitch. I'm working on it. That's why I'm recording this on GitHub. You can use a Jupyter notebook to do the necessary things, and you can either predict as 0, 1, 2. So I have predicted as the hard-coded value as 3. So at third index in the Sapphire dataset, our convolutional neural network is trained and is predicting that at third index the image is of airplane. So you can change this index and predict the results. The convolutional neural network will give the best results. So guys, this was an entire Python program, Python machine learning model to detect the images and to classify the images on the basis of neural networks. We have found that CNN convolutional neural network is the best neural network for the image classification model, and hence we have successfully built a machine learning model to classify the images on the basis of Sapphire dataset, that is Canadian Institute for Advanced Research dataset, which is the most commonly used dataset for training the machine learning and computer vision algorithms. This particular image classification model can be used in medical diagnosis or object detection in satellite mechanisms. So I hope guys the code was clear and precise enough. You liked this video. Please do subscribe to our channel, My Project Ideas, in order to get some more interesting stuff in different technical domains. Thank you so much, guys. Till then, see you in the next video. Till then, keep growing and keep exploring. Thank you.